Welcome back to another video. Today is another episode and we are going to look at how we can tackle the integration by part techniques, right? And under the integration by part, we have two methods, that is the formula approach and the tabular approach. But don't forget, we are always taught how to use the formula approach without the tabular approach. But the tabular approach makes work so easy, but it's very crucial because of the science involved. But apart from that, it's very easy and very snappy. Before I forget, Merry Christmas to everyone out there. Enjoy with care. As you enjoy, then you press on my content to enjoy as well. Don't forget to keep learning all the time. If you stop learning, that means you are dead. That's it. So, right, when it goes to every environment, there are rules. There are rules that governs every environment. So right here under the integration technique, precise by parts, we have some rules that governs the integration by parts using the formula approach. And right here, I'm going to show you all the rules. You have to follow them and integration by parts will be so easy for you. I doubt you. It's going to be easy, right? So let's begin. So the first set of rule is going to be if, that is the rule number one, if the problem is in the form of the following. Then, if the problem is in the form of the following: 1, x power n, e power ax dx, b, x power n sine into ax dx, c, x power n cos into ax dx. Then I will always advise you to, or that is the rule, let me say that is the rule, you choose or select your xn, right, to be the u, right? So you choose your u to be the xn. If you have this kind of question in the form of this, select your u to be s power n. The next set of rules is going to be rule 2. If the problem is in the form of the following: A, we are done with the first set of rules. We are going to the second set of rules. The second set of rules says that if the problem is in the form of the following: A, s power n, integral of s power n, ln x dx. B, if the problem is in the form of s power n, arc sine into ax dx, or integral s power n sine inverse of ax dx. C, if the problem is in the form of x power n, arc tan into ax dx, or integral x power n tan inverse of ax dx. Then you select your divine as xn. If you have the problem in the form of this, then you select your divine as Sn dx. This is the rule, the second set of rules. Let's move on to the third set of rules, and then we will start with problems. So the third set of rules says that if the problem is in the form of the following: 1. If the problem is in the form of the following: 1. Integral e power ax sine into ax dx, right? B. If the problem is in the form of this, then you choose your then you have to choose your divine as e power ax dx. So these are the rules that governs integration by parts. So don't forget, learn the rules very well, and then integration by parts using the formula approach will be so snappy, so easy for you as well. So let's start with problems on the integration by parts using the formula approach. Right? So using the formula method. Right? So we are going to take our first problem. So our first problem is the integral of x e power 2x dx. So looking at the rules that we learned right here, that means that we are going to choose our x to be u, right? So we let u equals x, right? So we can say that our du is equal to the x. Now we have identified our u. So the next term is going to be the divine. So our divine right here is going to be e power 2x dx, right? So when we integrate both sides, then this takes off this, then we have v equals, when you integrate e power 2x, you're going to have e power 2x all on 2 plus a constant of integration, but we don't need the constant of integration at this point, right? So now let's quote our formula for integration by parts. Right? This is our formula. Now we have all the parameters. So what do? We put in the items. So our u right here is x. Our v is e power 2x all on 2 minus integral of the v, e power 2x all on 2. Then our du right here is the x. Good. So what is left here is just simplification, and just integrate this and you are good to go. Nothing is difficult here anymore. Good. So right here we're going to have x e power 2x all on 2 minus, we can bring the half out, half integral of e power 2x dx. Good. So this right here, we integrate e power 2x again. Then we have x e power 2x minus this right here, minus half, then into, when you integrate e power 2x, you are going to have e power 2x all on 2 plus constant of integration. So this right here is going to be x e power 2x all on 2 minus 1 on 4, this and this, right? E power 2x plus c. So this is our final answer, but we can see that half is common to all of it, and e power 2x is common to the two terms. So we can say that when we factor that out, then we have e power 2x all on 2 into x minus half, right, plus a constant of integration. So this right here becomes our final answer to this particular problem. Very, very easy. I love the formula approach, and I also love the tabular approach. But what makes me love the tabular approach more is that it makes work so snappy when you have degrees more than one. Right, so let's look at the second problem. So the second problem is the integral of x 5 power x dx. This is what we have here. Now, looking at the rules that we learned, we can say that our u should be equal to x. So when we do that, it means that the u is equal to what? The x. So now we have the u, we can now go ahead and pick this as our v, the v, right? So we have the v equals 5 power x dx. So we integrate both sides, right? And then we have this takes of this, and we have v equals 5 power x all on ln 5 plus a constant of integration, but we don't need it at this point. Good. Now we have all the parameters, so we can state our formula. uv integral of uv should be equal to uv minus integral of v du, right here. Now we have our u, we have our v, we have our du. Good. So we can put in the parameters. So our u right here is x, and our v is 5 power x on ln 5 minus our v right here is 5 power x over ln 5. Then our du is the x. Good. So what we do here is that we simplify this and integrate the second part. So we have x 5 power x all on ln 5 minus integral of 5 power x all on ln 5 dx. Good. So now we can bring 1 on ln 5 out. So when we do that, we are going to have x power x ln 5 minus 1 on ln 5 integral of 5 power x dx, right? Now we can integrate 5 power x dx. So when we do that, we have right here into, when you integrate 5 power x dx, then we have 5 power x over ln 5 plus a constant of integration. So this right here, we can see that 5 power x ln 5 is common to these two terms. So we factor that out, and then we have 5 power x on ln 5 all into x minus 1 on ln 5 plus a constant of integration. So this right here, we can see that this right here is the solution to this particular problem. Very, very easy. So this is the second problem solved under the integration by parts using the formula approach, to be precise, right? So let's look at the third problem. Looking at the third problem, ln x all over x power 3 dx. This right here, someone may ask me, I said that you can only use the integration by parts when you have two functions that are multiplying, but this one is dividing. So what do? This right here, you can see that we can change the fraction to right, by changing the 1 over x cubed to x power negative 3. So this is the same as integral of x power negative 3 ln x dx. Very simple right here. So this, what we do here is that we have to be strategic in how we choose the u and the div. We learned from the rules that whenever you have x power n ln x dx, then we will choose our ln x as u. Don't forget that. So when we do that, that means that our u will be equal to ln x right here. So it means that our du is equal to 1 on x dx, right? Now we are done with this part. It means that this right here is going to be the div. So our div right here is going to be x power negative 3 dx. So when you integrate both sides, right, you're going to have this, take solve this, and you have v equals, when you integrate x power negative 3, you have x power negative 2 all on negative 2. Good. So now we have the parameters for v. We have u, we have du, all that. So we use, or we apply the formula. We apply the formula. So when we apply the formula, right, now our u is ln x and our v is this. So we have x power negative 2 all on negative 2. Then our v, our u right here is ln x. So we have ln x here minus integral of the v, which is x power negative 2 all on negative 2. So we have x power negative 2 all on negative 2 times our du is 1 on x dx. 2 times 1 on x dx. So we simplify this and integrate it the last time, and we are good to go. So right here, we're going to have, you know that x power negative 2 can be reversed to 1 over x squared. So we have negative 1 on 2 s squared because of the negative 2 right here, ln x minus, we can bring the negative half out. So negative negative is going to be positive half into x power negative 2 times 1 on x dx. So right here we're going to have negative ln x on 2x squared plus 1 on 2 integral of, you know that x power negative 2 can be written as 1 over s squared times 1 on x dx. Good. So this right here we have negative ln x on 2s squared plus 1 on 2 integral of 1 on x power 3 dx. Right? So this right here, we can reverse it. Right? So when we do that, so we have negative ln x on 2s squared plus 1 on 2 integral of x power negative 3 dx. So now we can effect this integration. So when we do that, it means we are going to have negative ln x on 2s squared plus half into integral of x power negative 3 is x power negative 2 all on negative 2 plus a constant of integration. So we have right here negative ln x on 2s squared plus, so this right here we're going to have negative 1 on 4 x power negative 2 plus c, right? So this right here we can see that we are going to have negative ln x on 2s squared minus 1 on 4s squared plus c. Good. So we can see that we have 1 on 2 s squared common to both terms. So we can factor that out. 1 on 2 s squared out. So when we do that, means we are going to have negative ln x plus that will be minus half plus c. So this is the final answer to this particular problem. This is the final answer to this particular problem. Very, very, very easy. You just have to follow step by step and you are good to go. So that is the third problem. Let's look at the fourth problem on this integration by parts. So our fourth problem is going to be the integral of x, cos x dx. That is our fourth problem right here. So looking at the rules that we learned, we have to let our x equals u, right? So let u equals x. So if u equals x, then means that our du is equal to the x, right? That is good. So now that we have identified our u, we can say that cos x dx be the dividend. So dividend is equal to cos x dx. So now we integrate both sides, and we have, when you integrate both sides, then v will be equal to, when you integrate cos, you are going to have sine x right here. So this right here, we have all the parameters. So what we do next is that we just substitute them into the formula, and then we are good to go. So right here, we know that uv du, and we have all the parameters. So just put them inside. Our u is x, our v is sine x, minus the integral of v. The v is sine, so sine x. The du is right here, the x. Good. Right here, we're going to have x sine x, right, minus the integral of sine, which is negative cos, right? So we have into negative cos x plus c. So we can see clearly that this and this, we are going to have positive. So we have right here s sine s plus cos s plus c as our final answer to this particular problem. So this right here, we can see that our final answer is sine s plus cos s plus c. And this is the final answer to problem number 4. So now we can go ahead and take our fifth problem. So our fifth problem is the integral of x squared e power 3x dx. Right? So this right here, looking at the techniques that we learned, it means that our s squared will represent our u. Good. So right there, we know that our u is equal to s squared. So it means that the u will be equal to 2x dx. Good. So it means that e power 3x dx will be the dividend. Right? Now we integrate both sides, and we have, so this takes off this, and we have v equals e power 3x all on 3. So now we have all the parameters. We can apply our formula. We can apply our formula as uv equals, right, and right here we have our u to be s squared, and our v is e power 3x all on 3 minus our v, integral of our v, times our du as 2x dx. Right. So this right here, we can see that we have x squared e power 3x all on 3 minus 2 on 3 integral of x e power 3x dx. So this right here, we can see clearly that when we integrate again, we will still be having x involved, and we have to reintegrate, right? So when we do that, then we are going to have x squared e power 3x all on 3 minus 2 on 3 So when we integrate this again, means we are going to have this times x e power 3x all on 3, then minus the integral of the function again, right? That is what is going to be. So we're going to have x squared e power 3x all on 3 minus 2x on 9 e power 3x minus x e power 3x dx. Good. So that we have to, this means that we have to integrate again, right? So when we do that, then we're going to have 1 on 3 x squared e power 3x right here. That is the first term I've written over there again. Minus this have to go in a very big bracket. 2 on 3x 2 on 3x times 1 on 3 e power 3x, then minus the integral of that, minus the integral of this right here. Great. So all this in a very big curly bracket. Yeah, great. So times 2 on 3 dx. Great. So this right here, when we do this very well, then we're going to have 1 on 3 s squared e power 3x minus 2 on 9 x e power 3x. Then when we integrate this very well, we are going to have this negative will affect this right here. We're going to have plus 2 on 27 e power 3x plus a constant of integration. When you integrate e power 3x back, you get 1 over 3 again. So 1 over 3 times 1 over 3 times 2 over 3, and that is 2 over 27 right here. So that is the solution to this right here. So this is the solution. Plus 2 on 27 e power 3x plus c. So this right here is our solution to this particular problem. So this right here, you see the process we went through to get the final solution. Let's use this same question and use the tabular approach and look at how it's going to be, how snappy it's going to be. So this right here, this same question, we are using the tabular approach. So this right here, the tabular approach, the skills that you have to learn in that you have to select your u to the function that you can differentiate to a constant, and then you select the rest to be the vein. That is the one that you'll be integrating, right? So our u right here will be s squared. So s squared and the vein will be e power 3x. So when you construct your table, it means that when you differentiate x squared, you are going to have 2x. Differentiate again, you have 2. Differentiate again, you have 0. Now you come here. Integrate e power 3x, and then you have e power 3x on 3. Right? And then you integrate again. So when you integrate this again, you have e power 3x on 9. Right? And then you go, the last part, you integrate again, they get e power 3x on 27. E power 3x on 27. Right? So that is this. Right? Now, what you do is that you apply the crucial aspects where this goes to this, this goes to this, this goes to this. And this, you effect this sign here, plus, minus, plus in that order. So this is where you have to be very, very careful, because if you forget this sign, it's going to harm you. So you have to be very, very careful when you are doing you are using the tabular approach. You have to be very, very careful, right? So this takes this, right? This multiplies this, but the sign is positive, so it's going to be s squared e power 3x all on 3. Then this multiplies this, but the sign over there is negative, right? So you have minus minus 2x on 9 e power 3x. And then this takes this. The sign in between is positive. So we have plus 2 over 27 e power 3x. And then we can see that we have the same solution. Don't forget your constant of integration. When you are done with everything, you add constant of integration. So that is the tabular approach. You see how snappy it is when we use it to check when we use the formula approach together with the same question when we just finished. So this, you can see that we are having the same solution. This is when we use the formula approach, and this is when we use the tabular approach. You can see that we have same solution. There must be no difference. It must be the same if only you apply the signs very well. So this is the fifth question. Let's move to the sixth question. So the sixth question is the integral of x ln x dx. So this question right here, naturally, when you just see this, you will be choosing x to be the u. but that is not the case. When you do that, you cannot work this problem. So x is not equal to u. You can't choose that. So let's go. Let your u equals ln x. So if that is true, then you can say that the u is equal to 1 on x dx, right? So far as you have been able to choose your u, then you can say that your dv will be equal to x dx. So integrating both sides means that this takes off this, and you have v equals integral of x with respect to x s squared on 2, right? So now we have all the parameters, so you can say that u v minus integral of v du, and that is u v. U is right here and the v is right here, so we have the v, which is s squared on 2, and the u is ln x minus the v, integral of the v, and the du is 1 on x dx. Good. So we can see clearly that we have s squared on 2 ln x minus half out. Then this takes one of this, so we have this right here. So we can see clearly that this is s squared on 2 ln x minus half, then integral of x will be s squared on 2 plus a constant of integration. But this right here, we can see that half s squared is common to these two items. So we can factor half s squared out, right? So when we do that, we're going to have ln x inside this, then minus half plus a constant of integration. So this has become the solution to this particular problem. So this is the solution to this particular problem. So easy. Just have to know what you are choosing for u and what you are choosing for dv, and that is the end of the work. So this is question number 6. Let's go to problem number 7. I promise to solve 10 questions, so watch out. Right? So our seventh problem is the integral of ln x dx. Right? This is our seventh problem. And this right here, we can't integrate this straight away like that. But we have to note that this right here means that you can clearly tell us that this right here is the same as this. This means that we have this right here as 1 times ln x dx. So interesting. So right here, we can say that we should let our u equals ln x. So the u will be equal to 1 on x dx. Good. So if you are able to do that, then means that we can say that 1 should be the dv. So dv equals 1 dx. So when you integrate both sides, then means that we are going to have our v to be x, right? So this right here, we have gotten all the parameters. We just go straight and use the formula. So when we use the formula, uv minus integral of v du, where our u right here is ln x, and our v is x. So we have x ln x minus integral of the v, which is x, and the du is 1 on x dx. So we can see clearly that this takes of this, and we have integral of 1 dx, right? So this right here, we're going to have x ln x minus integral of 1 with respect to x is x plus a constant of integration. So this right here, we can say that x out, then ln x minus 1 plus a constant of integration. And that is the end of the solution to this particular problem. Very, very easy. So that is the problem number 7. We go to question number 8. Question number 8. So question number 8 is the integral of e power x sine x dx, right? This right here we have, what can we do? Because none of these functions can be differentiated to a constant. So this means that we have to choose either of them to be the u, and the other will be the v. But the rule that we learned earlier on before we started, that we have to, when we have something like this, then we have to choose our dividend as sine x, right? So when we do that, that means that we are going to have dividend equals sine x dx, right? So it means that our integral of dividend, this side integral of sine x dx, it means we are going to have our integral of sine x is negative cos x. Then means that e power x will be the u. So we can say that u is equal to e power x. So the u will be equal to e power x dx, right? So right here we have all the parameters. What we need is the formula, right? So we have our formula, uv minus integral of v du, right here. And our u is what? E power x, and our v is negative cos x. So we have negative cos x, right? Minus our v, integral of our v, integral of the v, which is cos x, and then our du is e power x dx, right? So we go back again. So it means that we are going to have negative cos x e power x, negative negative is going to plus cos x e power x dx. So this right here means that we have to integrate this again, right? And when we integrate this again, we will get back to the question. So this is the first integration, means, but we are still having something to integrate, right? So we have to do that again. But when we do that, we'll get back to the question and we will apply some knowledge over here. So this here means that we have to choose so let's your dividend equals cos x dx. So if that is true, then integral of that right here will be v equals sine x right here. You see the integral of cos is sine. Then we can choose e power x as the u. So u is equal to e power x. So du is equal to e power x dx. Right? So we can see clearly that when we substitute, we'll go back to the question. So when we do the substitution, don't forget that our actual formula is uv, integral of uv equals uv minus integral of v du, right? So it means that this part you are going to have the real question, right? So this part is going to be e power x sine x dx equals uv, right? The first part, which is negative cos x e power x plus integral of cos x e power x dx. But we have found this right here as sine x and e power dx, right? So we can go ahead and say that negative cos x e power x plus integral of this again is sine x, right? Yep, sine x yep, so that's it. So when you integrate this again, that will be negative integral of sine x, right? This part will be negative, okay, plus e power x dx. So we send this to come and add up to this. So we have this right here. This comes here to add up to this, right? So when you do that, plus e power x sine x right here. But when we send this here, it means that we are going to have 2 into e power x sine x dx, right? And that should be equal to sine x e power x minus cos x e power x. That is what we are having so far. So this right here, we can say that we have 2i. This right here, we are representing it as 2i because there is 2 here. So this will be integration. This whole thing will be integration. So 2i equals sine x e power x minus cos x e power x, right? So this right here, we need I, so we divide by 2. We divide this 2 by 2. So we have our I equals sine x e power x minus cos x e power x all on 2, right? So we can say that our I is equal to sine x e power x minus cos x e power x all on 2. But we can factor e power x out. So when we do that, we have e power x out, sine x minus cos x all over 2. And that is the solution to this particular problem. And that is the 8th problem. Let's look at the 9th problem, and we will end it here. So our 9th problem is the integral of x sine x dx, right? So clearly from here we can see that our x will be the u. So we can see that u should be equal to x. So this means that our du is equal to the x, right? So if we have identified the u and the dx, then we can say that sine x dx be the dividend. So we have dividend is equal to sine x dx. So when we integrate both sides, we have v equals negative cos x. So when we apply the formula, then we're going to have u v minus integral of v du. Now our u is x and our v is negative cos x minus integral of negative cos x du is what? Dx. So you have negative s cos x, this negative positive cos x dx, right? So this right here, we're going to have this right here, negative x cos x plus integral of cos x is sine x. So we have sine x plus a constant of integration. But this, we can rewrite it as sine x minus x cos x plus c. That is the constant of integration. And this becomes the solution to this particular problem right here. The last problem is problem number 10. Then we are down the line. So problem number 10 is going to be our problem number 10 is x cos 4x dx. So clearly from here we can see what we are choosing for x and what we are choosing for the v. So we can say that our u should be equal to x. So this means that the u is equal to the x. So if we have gotten this, then it means that our dividend will be equal to cos into 4x dx. So when we integrate both sides, we have v equals integral of course is sine into the 4x all on 4, right? So far as we are done with the finding the parameters, all we have to do is to quote the formula. So quoting the formula, you know that uv minus integral of v du will be equal to, our u is x, and our v is sine into 4x all on 4 minus the integral of the v, sine into 4x all on 4 times the du, which is the dx, right? So right here we can clearly see that this, we are going to have x sine into 4x all on 4 minus 1 on 4 integral of sine x sine into 4x dx, right? So this, we are going to have this right here, x sine into 4x all on 4 minus 1 on 4 into integral of sine 4x is going to be negative cos into 4x on 4 plus constant of integration. So this right here, we can see that 1 on 4 is common to all, right? So we factor 1 on 4 out. We are going to have x sine into 4x minus 1 on 4 cos into 4x all on 4 plus c. But there is negative here, so you have plus right here. So that is the end of the problem. This is the solution to this particular problem. Very, very simple. So thank you very much for watching. I really appreciate your time. Please don't forget to press on the notification bell and I'll give you more updates. This is the formula approach of integration by part. I will also do the integration by part using the tabular approach. But that one, when you are using it, you have to be very, very careful. Though it makes work so easy, but you have to be very careful. Thank you very much. Enjoy your Christmas. As you enjoy, press on my content and enjoy as well. Bye bye.